This experiment is an acid-base titration. It is experiment number 7 from the Advanced Chemistry with Vernier book written for college and AP chemistry students. It's also very similar to experiment 24 in the Chemistry with Vernier lab book that's written more for high school students. And the lab is a acid-base titration with hydrochloric acid being titrated by sodium hydroxide. We're using a few pieces of equipment to do this titration. The stir station here, where we're going to have our micro stir turning on the bottom of our pH sensor, which is next. I'm also going to turn on the light on the stir station so you can see that a little better. So we have a micro stir here, which has a little paddle wheel on the bottom of the pH sensor that we have in our hydrochloric acid solution. The drop counter is this part here. It actually counts the drops that fall through from this reagent reservoir into the beaker, and it counts them by breaking a little infrared beam and counting the number of drops. The software then converts that into a volume in milliliters. The reagent reservoir is just held onto this ring stand, which is part of the stir station. The pH sensor and drop counter are both attached to the LabQuest interface, and they have auto ID'd, and so we're ready to go. I just need to tap on the collect button, and now it's waiting for a drop to come through. I open the stopcock on my drop counter, and my drops come through every 1 or 2 seconds or so. So this is counting away, and the titration will progress until we stop it. I put some phenolphthalein in here, and you can see as each drop goes in, we're getting some pink. It's lingering longer with each drop, so we're really close to the equivalence point now. And it looks like we are there. We'll let it keep dropping a little while longer so we can get an upper tail on our titration curve and come back and analyze it. So here's our finished data for our titration. When I tap somewhere on the graph, it's going to give me the pH and volume for wherever I tapped on the data. We want to find the equivalence point, and it's going to be somewhere in here, but it's kind of hard to tell. So there are some better ways to tell than just by visually looking at the pH data. If we go to the table tab, we could scroll through and look at the changes in pH and find the largest jump. That would be one way, but there's a few other ways that are even better. One is to create a derivative of our data with a new calculated column. So I'm going to change the name from calculated column just to D1. We're going to do a first derivative here. And the equation, if I scroll down, is already in here as first derivative of y with respect to x. And say OK. And it automatically then plots that for us on the graph. The equivalence point would be at the peak of that right there. Volume of 3.263 milliliters would be our equivalence point using the first derivative as a method to find that. Another way is the second derivative. I'll go ahead and create that column too. Under table, new calculated column. We'll name this one D2. And the equation second derivative of y with respect to x. Okay, here we have the second derivative, and what we really want to see is the point where this line crosses 0. So if I do a selection right around that point and then do a zoom in, you can see right there where it crosses. I'm going to select a region of this line where we have a linear portion and do a linear curve fit on that section of the second derivative. So my fit is linear. All right, now that I have a linear fit, I can turn on interpolate and get very close to 0 right there, where I'm as close to 0 as I can. My volume is 3.2680. So that gives us the exact equivalence point using the second derivative, which is probably the most accurate way to do that. So that was a strong acid, strong base titration. In the advanced chemistry with Vernier book, that lab goes on to do a strong base with a weak acid using acetic acid to titrate. There are also other titrations in these two books, diprotic acids and things like that. So many different titration options for you in the Vernier chemistry books.